Everyone, and welcome to another episode of AI Climbing with Sheikh. And the fact that I receive number of questions that I do share a handful of information on the AI models and the algorithmic and application side. And what about data? And we all know, right, that AI is as good as the data it is trained on, the speed, how you will incrementally update and manage those. And that is where the spark really comes in, right? And I just want to break down this journey because when you talk about the data and AI, there are different frameworks, right? And you have learned about the PyTorch from Facebook and TensorFlow from Google with all of this CUDA stuff. And then there is a Spark. Spark is more like universal framework because anyways, both PyTorch as well as TensorFlow use it for the managing data. And then the whole notion is, right, like you distribute the data between different sort of workloads, and Spark actually manages it in a way. And in this video, we will be touching both the architecture side and do actually solve a problem, right, with some code, which obviously you can find on GitHub. And the use case here is there are a lot of cameras on the Vic roads here, and normally used to give you fine, but then I try to retrieve it through the public APIs. And the problem is how we can classify based on those recording different accidents and different rating of those accidents. You can do a lot of stuff, right, like linking it with healthcare and this and that. But yeah, that's the whole notion. And let me try to give you a architecture view first. So anyone who worked on cloud, right, will find it quite relevant because controller and worker is a standard Kubernetes or a cloud manifest. But then the whole idea here is there is a Spark initiator, which is more like a orchestrator. So look, as you will distribute the one big machine learning thing and data between different nodes, you will chunk it, and then you need to integrate it, manage it. So how it works, the all of those ID and information is managed by the Spark initiator, and it will rely on the controller for the job scheduling. So ultimately, the two horizontal legs between the top, these boxes will help to run the jobs in a distributed way. So how it works, the Spark, once it will distribute the jobs, it will go to the controller, ask for the all of those workers and resources, and once those are provided, then it will distribute the jobs and then get the results, report it, and all pretty much the stuff, right? Before I going much, it is important to understand that the ML package for running the Spark you will hear about is the ML lib, right? And it runs on the distributed Spark architecture, and it can run a lot of both the processing and training models, right, in a distributed manner. And the good thing is it provides APIs in many languages. Obviously, Python, Java, and R are my expertise, but then Scala and few other frameworks are readily available as well, right? And yeah, so with this, perhaps let's try to understand a bit of how it works. And you can see, like, don't go into boxes, but largely it is more like the CI/CD or a pipeline view of the world. And obviously, just like you do in the pandas and scikit, you will load this part data frame and then transform it, and then there are a lot of pre-built or ready models, right, like the regressor models and the traditional linear and logistic regression, and then you can classify it. So the whole idea is you will train. It's pretty much how the machine learning model work, right? But I really want to show it's not just about the loading data. in a distributed way. It's also about running some jobs, and actually you can do some basic models in Spark itself. And the last piece is ML Leap. ML Leap is more like a serialized or a runtime framework, right? Here you can export your models and run it in a real time, more like inferencing or day two sort of stuff. So that is how the overall thing works, and then naturally on the right bottom you can integrate via APIs with number of AI applications. This is an important slide, and therefore I want to spend some time. So as you can see, right, the first piece is the preparing of data, and as you can clearly see, right, like from the Spark, once you will create a session and we will talk about it, you can actually use, pretty much standard functions like spark.read to load any of the data file. And so it's more about preparing data and then the model training, right? There are large sort of models which you can actually use in Spark. But then before running the models, right, as you can see the transformers, right, so you can do lot of transformations. For example, scalar transformation, linear transformation, ReLU transformations, and there are pretty much standard functions, right, available to do that. And after that, as you can see in terms of model training, you can call number of those classification models, and then the model evaluation, right? So there are a lot of utilities for cross validation and model evaluation and all of those aspects. And one thing which is important but I have not touched deeply is the pipeline. So all of those tasks you can actually link, right, to build a pipeline, right, similarly to the scikit. And you can sequence transformation and model training. Consider it like this, right? Like you can, for example, import a pipeline, import different model classifiers, and import features. And then the good thing is you can call a pipeline with the stages, right? For example, the stage one can be a tokenizer, other can be a hashing of TensorFlow, the third one can be linear regression. So pretty much do one, two, three, four in the way, and then you can actually save the model itself, right? So with this, we come to the end-to-end architecture, and I actually got this from a friend and who do a lot of CI/CD with ML ops. And the point I want to make here is like whatever cloud operations you do, right? Because you can't store data in this gate in a way because data is very big. Ultimately you will store in some sort of S3, big data query from Google, or S3 from AWS or Minio. And then there are some ML ops processes like the more like the Cube Spray, Kubeflow, and others. And then you can actually run those right onto the Spark. As I said, in this case again, ML Flow will be talking and working with the Spark or originator. And yeah, that's pretty much an important thing I wanted to show you. And now let's try to go a deep into how to solve a problem, right? And in order to solve a problem, let me first try to show you the file which I will be using. And where it is. Alrighty, just give me a moment. Okay, so I will be pulling the file. And Okay, and you can see it's just loading. Just give me a moment. It's a big file. But it's pretty much a standard CSV file with a number of IDs. And as you can see over here, if I pull it up here, it's a big data set, right? There's a lot of information in it. And yeah, we will be trying to see. So that's pretty much all the camera feed and the data, how it is output over here. And next, I will pull some of the like workflows and how we have done it. So again, I just load this into into this collapse. Again, you can do it locally as well, but I just thought is a bit easy to run actually on the collabs. And yeah, so let's start. And as you can see over here, we are initially running some libraries, and then we will import this part session. This is the node, right, which I actually told you in the start. And then that's pretty much how you will load the data. I think there is no rocket science over here. And data pre-processing, right, will be coming next. So this is just like, after loading you show, and how different columns are, what are those different columns are. And that's important that we call it feature engineering. And the notion, as you can see, right, so there is text data in your data set, and then there are numbers, right, and you need to find a way which features you will use to train the model. So in this case, as you can see, this categorical data needs to be converted into numbers or indices, right? And as you can see over here, I am trying to like convert those, so using the string indexing function, right? And all I am doing is I am passing it and convert into numbers. Again, not rocket science. And then there are some numerical data, and then I will combine all, like as you can see, combining two matrices. So ultimately your whole data set becomes one set of numbers, because models just process numbers at the end of the day. And from there, as you can see, we are also converting it into a vector, right? Again, vector, as you know, is an important concept over here, because feature vector means that each of this row you convert into a number of items in n dimensions, right? And then we use for the training. And based on this, now we will call a pre-built model or classifier, right? Classifier is the right word. And as you can see, we import it and import the pipeline. And what we are essentially doing over here, as you can see, that we are passing those inputs to the logical regressors, right? As you know, above we have already combined all of the features, as you can see over here, right? Like all of those are already in the form of the vector over here, which is in the assembler, right? And then what we are doing over here, as you can see, it is defining a sort of stage, right? And as you can see over here, it is essentially just passing, right, like the number of stages as the indexers, right? As you can see, what is indexer? Again, you each consider each row have those ID, and then you are, it's pretty much a very most simplest way of a pipeline over here. And then again, you do some data processing, remove those columns which are empty, and divide your training data, and put the model. Again, I do a basic one. Normally, you have a labeled or a set data, and then you can have any test data, right, which you want to classify. And Then you will run the model. As you can see how it will work. You just call the model, you already have a model and you will predict it, right, using the transform or predict function. And as you can see, right, you will select the features, right, based on the feature labels, prediction, probability. So you can, up to you, you can select others as well, but we are just using this four. And then pretty much we will run some evaluator to return the results, right? And that's actually pretty much all of the fact. And here the accuracy is one, obviously, because all is the label data. And because we trained model is more like a classical overfitting problem. But here I just try to show you, how using a very simple way, right, you can actually run the model and classify it and make it work for you. So I will leave the rest to you, and I hope you are making some sense and see how this thing works. And thank you. If you like, don't forget to like this video, subscribe, and let's continue our journey together. Thank you.